Hi everybody, in this video we're gonna continue our work of optimization problems. So this example is that we need to minimize the cost of building a fence. So we have a fence must be built to enclose a rectangular area of 20,000 feet square. Fencing material costs $3 per foot for the two sides facing north and south and $6 per foot for the other two sides. Find the cost of the least expensive fence. So these are keywords. Least expensive fence lets me know that I need to minimize expensive. So I need to minimize the expense. So let's say we want to minimize cost. So once you know what you want to minimize or maximize, then our task is to find that equation. So what is the cost equation? And for things like this with that we have a rectangular area, a picture helps. So I'm going to draw, I'm going to draw a rectangle. And let's see, we have a fence must be built to enclose a rectangular area of 20,000 square feet. Okay, so the area here is 20,000 square feet. Fencing material costs $3 per foot for the two sides facing north and south. So north and south. So this one's cost $3 per foot. The north facing and the south facing. And the other two cost $6. So my picture is probably not accurate, as probably the longer sides should be the ones costing more, but that's okay. That's going to come up in our dimensions. Okay, so we need some variables here because I need to be able to write the cost equation. So I need to know for what values of x, or for what values of this rectangle. So let's call the length x and the width y. So let me make another picture with just the variables. So x and y. So the fencing material, so fence means around the rectangular area. So around is the perimeter. So we really want to minimize perimeter, but we need to use the perimeter to find the cost equation. So the cost is the cost of the north and facing sides, north and south sides, plus the cost of the east and west. So we have four sides. So the north and south cost each $3, and these are the x. So if this is x, that's also x. So I have two of those. Since that's y, this is also y. So that one costs $3 per foot. This one costs $3 per foot. And the y size, I have two of those. So for the north side, I'm going to have the $3 per foot times x feet. You don't have to write the units, but I'm just pointing out. So the other one is, so say that's the north, the south will be $3 per foot times x feet again, since I have north and south, plus the cost of the other two. The other costs $6 per foot, and you have y feet for, say, the east, and $6 per foot times y feet for, say, the west. So notice here that the feet, some dimensional analysis, cancel, and we're left with dollars, which is what we want. Cost should be in dollars. So my cost equation is going to be 3x plus another 3x plus 6y plus another 6y. So the north side, the south side, the east side, the west side. So the cost in total then is 6x plus 12y. But we have that problem again, as we did in the previous example, that I have two variables. And this is a problem because I cannot take the derivative When I have two variables, I need one variable. So we need to write cost in terms of one variable, in terms of only one variable. And this is where we need our helper equation or the constraint. So what is the constraint here? So our helper equation, I call it the helper equation, but the more formal name is the constraint. The constraint is that the area has to be 20,000 feet square. So the area is 20,000 square feet. But that's the area of this rectangle. The area is length times width. So the area is x times y. So x times y equals 20,000. So I need to replace either x or y. So which one is easier? In the previous example that we did, we saw that y was easier. But here, it doesn't really matter which one. But we're used to seeing functions in terms of x. So I'm going to solve for y. Solve for y here so that I replace y there and I'll have x. So I'll have x there and x there once y is replaced. So that's why I solve for y here. So divide both sides by x. So 20,000 over x is y. So now I'm going to take this and put it into my cost equation. And because I'm going to replace the y with an x, this is going to be c of x is equal to 6x plus 12y. And y is what I'm putting in from here, 20,000 over x. And let's simplify it. So I'm going to get the cost is 6x plus, what's 12 times 20,000 is 240,000 over x. So this is my function now in terms of just one variable. Notice that before I just said cost and I had two variables. Once I've used my constraint helper equation to solve for one of the variables, substitute it back, and now that I have in terms of one variable, now I give it the function notation of the cost as a function of x. And now I want to minimize the cost. Minimize the cost means I want to be able to find the derivative and find critical numbers. So we're going to take the derivative with respect to x. So I'm going to have c prime of x is equal to, let's rewrite it. Since I need to take the derivative, I want to be able to use the general power rule. So I'm going to say x to the minus 1. That's going to help me take the derivative. So I'm going to have the derivative of 6x is 6. And the derivative of 240,000 x to the minus 1. General power rule says bring the minus 1 to the front. So I'm going to have minus 240,000 and decrease the power by 1. So minus 1 is minus 2. And we want to set the derivative equal to 0. So I'm going to have 0 equals 6 minus 240,000 over x squared. Rewrite it with the positive exponent and solve for x. So 0 equals 6. Multiply both sides by x squared. So let's do that here. Multiply both sides by x squared to get rid of the x squared in the denominator. So when I multiply by x squared times 6 becomes 6x squared, and x squared times this, my x squares are going to cancel. So I just get minus 240,000. And now solve. Add 240,000 to both sides equals 6x squared. Divide by 6, and this is just 40,000. Quick way to do that is just take 24 divided by 6. That's 4, and so you get the zeros still in there. And take the square root of that. So x is going to be the square root of 40,000. which is 200. Plus or minus 200. Anytime you take the square root of something, you get plus or minus, but x is representing the length of a rectangle, so it can't be negative. You can't have a negative length. So we're going to say length cannot be negative. So therefore x is just a positive 200. So what's y? Well, let's go back to the question. What were we asked to find? So we were asked to find the cost of the least expensive fence. So it's not asking me to find the dimensions of the rectangular area that's going to use the least amount of fencing. It's actually asking me to just find the least expensive fence. So find the cost. So my cost equation is over here. So let's go to it. So 6x, so let me rewrite it. So C of x was 6x plus, it was 240,000 divided by x. That is a 0. It kind of looked like a 6. 240,000 divided by x. And I know when x is 200, when x is 200, what will the cost be? So the cost when x is 200 is going to be 6 times 200 plus 240,000 divided by 200. So we get 200 times 6 is 1200, and 240,000 divided by 200 gives us 120. So the total cost here is, what is this? So add 120 to 1200, so we get 1320. So that would be the cost of the least expensive fence. So the minimum cost is 1,320. If we wanted to know the dimensions of the area that we can enclose for this amount of fencing, then we will say, well, I know that the x is 200 feet. So you find y, and remember we found y above was 20,000 divided by x. So y was 20,000 divided by x, so that will be 20,000 divided by 200. So get rid of 2 zeros. So it's really 200 divided by 2, which is 100 also. So it will be a square. I'm sorry, no, that's 200 and that was 100. So the rectangular area that we can enclose is going to be a 100 by 200 rectangle. And based on what we were told, right, x represented the north and south, so those are the longest. So we have 200 there and 100 there. So this will be the dimensions of the rectangular area that we can enclose with the minimum cost of 1320.